Section 1.8, we will combine functions and compose functions, and we have to be careful. Those are two different things. Sum, difference, product, and quotient are all combinations. So the sum combination is pretty straightforward. F plus g of x is the f function plus the g function. The domain is everything in common to both f and g. So things that you can use in f and things that you can use in g. The difference function, same idea. Same idea with domain as well, everything in common to both. The product function, and I'll use a dot just to emphasize that that's multiplication. Same thing, everything common to both. The quotient function, take the f function over the g function. Now we have to be careful here. There's a little bit more to it. Everything common to both, and the added idea that the g function cannot equal 0 because that's in a denominator. Now for this part, it's going to be, you'll need to be pretty careful about writing kind of small here. There's not a lot of room there, and there's quite a bit to do. So try to write small if you can. We'll start by looking at the domains of these. Now these are both polynomials. Polynomial functions do not involve fractions or square roots. So we don't need to worry about a negative under a radical at any point here. We don't need to worry about a 0 in a denominator. So the domain of the f function is all real numbers. The domain of the g function is all real numbers. Excuse me. So we really don't have any worries with our domains for the first for the first three parts, meaning the sum, the product, or the sum, the difference, and the product. So we'll start with the sum. F plus g of x, that equals f of x plus g of x. So we take our 2x plus 5, and we add f of x is 2x plus 5, g of x 2x squared plus 3x minus 5. We combine our terms. 2x can go with the 3x, and it looks like the plus 5 and the minus 5 cancel. We'll put that in order as well. 2x squared is first, plus 5x. The domain is what is in common to f of x and g of x, to those domains. Since we can use any real number in f of x and any real number of g of x, what those have in common? All real numbers. And now remember, it is important that you organize your work in a way that I know which is which. So I think that's pretty clear here. On to the difference function, f minus g of x. We take f of x and subtract g of x. Here's where we need to be very, very careful. We must use parentheses here because we're subtracting the entire g of x function from the f of x function. I really think it's worth writing down the step where we apply that opposite sign to everything after it. Then we'll combine our terms. Our squared term is negative 2x squared. Our x terms, negative 3x positive 2x. And our constant terms, plain old numbers, positive 5, plus 10. The domain for the difference function is whatever's in common to f of x and g of x. So they're both all real numbers. that domain is all real numbers as well, and I hope it's pretty clear that that's from the difference function. Product fg, meaning f times g of x, is f of x times g of x. Now, I'm going to show you two ways to multiply that, vertical and horizontal. The vertical way, we distribute both parts of the binomial to all parts of the trinomial. So I'll start with the 2x, multiply that by everything. 4x to the third plus 6x minus 10x. Then I'll multiply the positive 5 times everything. Positive 10x squared, positive 15x, negative 25. And then I'll put terms together. 4x to the third is the only cubed term. 10x squared. And there's the mistake. I know you caught that. 2x times 3x is 6x squared. You probably already have that fixed on your paper. 16x squared. Negative 10x, positive 15x, positive 5x, negative 25. Now, another way to do that is to multiply vertically. In that case, I probably want the trinomial on top. So this is just an alternate method here. Hopefully we'll come up with the same thing. Positive 5 times negative 5 is negative 25. Positive 5 times positive 3x is positive 15x. Positive 5 times 2x squared is 10x squared. 2x times negative 5 is negative 10x. I think I'll write that here in this column. 2x times 3x is positive 6x squared. And 2x times 2x squared is 4x to the third. Now, we add going down. And we get the same thing. 4x to the third, positive 16x squared, positive 5x, negative 25. Same domain as we've had. Whatever's common to both f and g, well, those domains are all real numbers, so the domain of the product is all real numbers as well. Now for the quotient. Take our f of x and put it over g of x. Now remember, to simplify here, we must factor first. Now there's no guarantee that this even simplifies. We might be done, but we need to try. So I'll keep the 2x plus 5 in the numerator. Thinking that denominator might factor, let's see, 2x times x has to be 5 times 1, and the signs will be different. So I think that will work with a 5 and a 1, 2x, 5x. I want the positives to win, so that's a positive and that's a negative. The 2x plus 5's cancel, so the quotient is 1 over x minus 1. Now, here's where we have to be careful of the domain. We can't have a 0 in the denominator. So, I need to look at what values of x could give me a 0 in the denominator. And it's important that we look back here, not just there. So, zero product property and a little mental math here. We have two things that x cannot be. For this to be 0, 2x plus 5 would have to equal 0. 2x would have to equal negative 5. X would be negative 5 halves. X also also cannot be positive 1 because of this binomial. So our quotient function is 1 over x minus 1. The domain's a little trickier that time because we do have a denominator. Same situation here. This time, though, the domains are a little more interesting. The domain of f of x is, well, let's see, x minus 2 has to be greater than or equal to 0, so x has to be greater than or equal to 2. The domain of g of x, 4 minus x, has to be greater than or equal to 0. So the opposite of x has to be greater than or equal to negative 4. Divide by negative 1 and flip the signs. X less than or equal to 4. So remember, the domain for the sum, difference, and product is whatever those two have in common. Now, for these problems, putting these together, well, isn't really going to be as exciting, meaning f of x and g of x, we can't combine those. Those are not like terms. So that's what it is. The domain is whatever these two things have in common, which is x is between 2 and 4, including both. The difference function, and those parentheses are important as well, f of x minus g of x, it's pretty much the same idea. We can't really subtract these because they're not like terms. They don't have the same radical parts. So the only change is we have minus instead of plus. Same idea with domain. The domain is whatever's in common to both of them. Now, multiplying and dividing, there's a little bit more that we can do because you can multiply. It's just like fractions or anything, or other things with like terms. You can multiply anything you want. So the square root of x minus 2 times the square root of 4 minus x. Multiply those under the same radical. We will just multiply that out using FOIL. So let's see. First, outer, inner, last. Now in general, we'll put that in a more standard form. The same domain. The domain of the product function is whatever the domains of the two functions have in common. And you'll see I'm being a little bit sloppy with, well, just about everything, but I'm not being as careful with the domain here. It's the set of all x such that. I hope that's okay. The quotient is going to get a little bit more complicated. And for f over g of x, remember that's f of x over g of x. So we have to take the square root of x minus 2 over the square root of 4 minus x. We need to be a little concerned about the domain there, and we need to do some work to simplify that. We'll do the simplifying of that and the domain part in the next video.